So let's start by looking at the conceptual schematic of what you're going to see on the measurement table. So basically there is a light source with a fiber. The fiber emits a cone of light. That cone of light is collimated by the lens. And then the collimated light passes through the windshield. Over here, there is a shock-hardened wavefront sensor. Now, the size of the sensor is smaller than the size of the whole collimated beam. So in essence, the sensor only probes a small area on the windshield. And so the measurement consists actually of two steps. Essentially, it's measuring this collimated beam when the windshield is not inserted into the path, and then measuring the same beam after inserting the windshield and probing the quality of the transmitted collimated beam with the sensor. Here's the measurement setup. So again, we have the light source and optical fiber. So the light is emitted from this point over here, and then it's collimated by this lens. And then here we have the shock-hardened wavefront sensor, and it's mounted on a stage that controls the height, the horizontal direction position of the sensor, as well as the angular orientation of the sensor. And the sensor has already been aligned in such a way that the axis of the sensor is actually parallel to the collimated beam. And currently, there is no windshield. This is the software that acquires and controls the wavefront sensor. This is the shape, a visual representation of the wavefront, essentially a cross-section of the collimated beam. The important parameters here is peak to valley. That kind of shows the flatness of that wavefront sensor. And then the overall quality of the wavefront sensor is provided by the number of Zernicke coefficients. However, in our case, we don't need, or we're not interested in such a detailed structure of the wavefront sensor. We are only interested in knowing what is the angle of the collimated beam after we insert the windshield. So currently there is no windshield, and so the sensor has been aligned parallel to the collimated beam, as well as it has been calibrated to remember the current quality of the collimated beam. After we will insert the windshield, we will then measure again. And so essentially the measurement of the angle is the comparative measurement of the wavefront before and after inserting the windshield. It's sort of like if you're trying to weigh a food that's on the plate. You weigh the plate alone, and then you weigh the food with the plate, and then the difference provides you with the weight of the food. The same concept applies here. You measure the wavefront before you insert the windshield, and then the wavefront after you insert the windshield. So here now I'm going to insert the windshield. And I'm going to move it so that the collimated beam is passing through the hot area. So you can see the markings on the windshield that indicate the location of the hot area, and the collimated beam passing approximately through the center of that hot area. But the location that we're probing is with the wavefront, with the shock-hardened sensor, is somewhere here, so you can see it better. So now this is the software that corresponds to the measuring the wavefront, transmitted wavefront after we inserted the windshield. So now we can see that peak to valley is much larger than what we saw before, and also from the picture of it we can see how the wavefront is actually tilted. So the software has in it a function that calculates the angle of that tilt. This function is accessible in the menus, and so over here, as part of the parameters that it shows for the transmitted beam, it shows pointing angle. pointing angle X and pointing angle Y in milliradians. So the software itself does not have a function that converts those tilt angles into the wedge angle. However, we wrote a short tool in Excel where I am going to enter those numbers that we saw on the previous screen. And it calculates the wedge angle of the windshield. So it requires the input of those two measured angles from the wavefront sensor software, as well as the refractive index of the windshield material. And this is the end of the demo of how to use the Shack-Hartmann wavefront sensor to probe to measure the wedge angle of the windshield at a location within the HUD area.